find the limit analytically, which means algebraically. So we're going to try to find the limit as x approaches 2. So algebraically just means try to plug in the 2. If I plug in the 2, I will end up getting 0 over 0. That does not mean the limit does not exist. Just means I can't do it that way. So I'm going to try to factor instead. This will factor into x minus 2 times x minus 1. The denominator is a difference of squares, so it will factor into 2 minus x and 2 plus x. Well, 2 plus x. All right. I do notice that I'm almost able to cancel the 2 minus x and x minus 2, but they are opposites of each other. So in the denominator, I'm actually going to factor out a negative 1. So I'm going to have x minus 2 over x minus 1 over negative x minus 2. So if I factor out a negative, it does become its opposite, and I still have 2 plus x. Now the x minus 2's cancel, so I have x minus 1 over negative 2 plus x. My entire goal is to plug in 2 for x, and I am now able to do so. So now I will plug in 2. So if I do that, I'm going to get 2 minus 1 over negative 2 plus 2, and that reduces to negative 1/4. So that would be my limit. Number 18, let f of x equal the piecewise function. Find the limit as x approaches negative 2. So I know that in order to find the limit, I do need to make sure that the limit from the left equals the limit from the right. So I'm going to find the limit as x approaches negative 2 from the left, and the limit as x approaches negative 2 from the right, and hopefully they are the same answer. So if I approach negative 2 from the left, I will be plugging negative 2 into the upper function. So I'll get 3 times negative 2 plus 4. That will give me negative 10. And then to get the limit from the right, I will be plugging it into the bottom function. So I'll get negative 3, negative 2 squared plus 2. That will also give me negative 10. So since my limits from the left and the right matched each other, my limit will be negative 10. Okay, number 19, find an equation of the tangent line and normal line to the graph of f of x equals 2x plus 1 cubed at negative 2, negative 27. So whenever we're looking for a tangent line, we will have y equals mx plus b. To get that m, we will be finding the derivative. So to find this derivative, I'm actually going to turn it into a chain rule problem. So this will be u cubed, this will be my u. Right, so when I take the derivative of u cubed, it's going to be 3u squared times the derivative of my u. The derivative of my u would be 2. So that will equal 6u squared. And then just replacing the u, we'll have 6 times the quantity 2x plus 1 squared. Okay, I know that what's happening is that x equals negative 2, so now I'm going to plug negative 2 into my derivative. And when I do that, I will get 54. What I have just found is my slope. Okay, so for the first part, my tangent line, I know my y is negative 27, my slope is 54, my x is negative 2 plus b. So I'm going to have negative 27 equals negative 108 plus b. I will add 108 to both sides, and I will get b is equal to 81. So my tangent line is going to be y equals 54x plus 81. If you chose that to write that in point slope form, that would have looked like y plus 2 equals 54x plus 27, which is an equivalent answer, which is fine. Okay, the normal line, please remember normal lines are just perpendicular lines, so I'm going to find the perpendicular slope, which would be negative 1 over 54. Now I'll go through that same process. So negative 27 equals negative 1 over 54 times negative 2 plus b. That will give me negative 27 equals negative 1, or positive 1/27 plus b. If I subtract 1/27 from both sides, I'll get negative 27 and 1/27. So my equation of my normal line will be y equals negative 1/54 x minus 27 and 1/27. Okay, without doing all that work, I could have also put my answer in point slope form, which would have been y plus 2 equals negative 1 over 54 times the quantity x plus, well, I have those backwards. It should be plus 27, and this should be plus 2. So same thing on this one. There we go. And that would do it. Okay, number 20, use the definition of derivative to find y prime. So definition of derivative, please remember, is f prime of x is equal to the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. If you would prefer to use h's, go right ahead. So now what we're going to do is take this x plus delta x and put it wherever we see an x. So we're going to have x plus delta x cubed plus 3 times x plus delta x minus 2, and then minus f of x. Well, f of x is just the function x cubed plus 3x minus 2, and this is all over delta x, okay? If you remember Pascal's triangle, you will find that very helpful. And if I'm going to a third power, it's going to be 1, 3, 3, 1. We'll go x cubed, x squared, x, and then the x drops out, and then we'll go delta x cubed, delta x squared, delta x, and then the delta x drops out, and plus is in between all of them. Okay, and then plus, I'm going to distribute that 3, so I'll get plus 3x plus 3 delta x minus 2. And then I am going to distribute the negative, so I'll get minus x cubed minus 3x plus 2, still all over delta x. Now let's see what will cancel. The x cubes will cancel, the 3x's will cancel, and the 2's will cancel. So I'm left with 3x squared delta x plus 3x delta x squared plus delta x cubed plus 3 delta x, still all over delta x. Okay, now in the numerator I notice that I can factor out a delta x. So when I do that, I'll get 3x squared plus 3x delta x plus delta x squared plus 3. Still all over delta x. So those are gone. Now my whole purpose in doing that was so that I can let the limit as delta x approach 0. So if I do that, 3x squared plus 3x delta x plus delta x squared plus 3, anything that has a delta x in it will drop out because it will become 0, and I will be left with 3x squared plus 3, which will be my derivative. And if you look up at the top, if you did that the short way, you would get the same thing. Okay, 21, a particle has position given by the equation x of t equals 5t cubed minus 3t squared plus 7, using t is greater than or equal to 0, so we're not going to use a negative time. At what value of t does a particle change direction? Well, if a particle changes direction, it's moving from going one way to the other, which will deal with the velocity. So we are going to make a velocity chart on this one. Okay, so velocity, the velocity is just derivative of position, which will be 15t squared minus 6t. To make a velocity chart, we do need a critical number, so I'll set the velocity equal to 0. And when I do that, I'm going to factor out a 3t. That will give me 5t minus 2. So my two critical numbers are going to be t equals 0 and t equals 2/5. So now I'm going to make my velocity chart, and 0, 2/5. I'm going to scribble off this left side because we don't have a time that's less than 0. If I pick 1/5, which would be between 0 and 2/5, I'm going to get a negative velocity. And if I pick a number bigger than 2/5, such as 1, I will get a positive velocity. So where does the particle change direction? It is changing direction at t equals 2/5. And the reason for that, it does say to justify your answer, that was because velocity changes sign. Okay, part B, it says, what is the acceleration of the particle at t equals 3? Well, we know acceleration is just the derivative of the velocity. So taking the derivative of the velocity, we're going to get 30t minus 6, and it does just ask us to find the acceleration at 3. So if we plug in 3, we will get 84, and no units will be necessary because no units were given in the problem.